In this video, we're going to continue our discussion of power systems by talking a little bit more about three-phase power and then a little bit about three-phase motors. This is important as you start working in heavier commercial equipment, which is why we put it with the advanced refrigeration material. So up until now, we've been talking basically about single-phase power. It's a single sine wave that modulates 60 times per second running between a positive and a positive. Motors, other than shaded pole, have a start winding and a run winding. L1 and neutral, or L1 and L2, are standard sources. This is an example of single-phase power. Now, single-phase power has a few problems, mainly that the power pulsates and modulates through zero 3 times on every circuit, or on every cycle. So we're going from a positive, we're going down through neutral, which is 0, then we're going to a negative, then we're coming back up through 0, and we do this on the complete sine wave 3 times each cycle. Okay, 1, 2, 3 to get our full 360 degrees. So anytime we're going through 0, we have a pulse in the power that is either not a negative, it's not positive, it's not negative, it's not 120, it's not 240, it's 0. So three-phase power contains 3 sine waves that run 120 degrees out of phase with each other. So if you take a look at this, any point in time, if I were to put a line, let's see if we can actually do this. If I put a line right down, let's go back here. Okay, if I draw a line in any point in time, okay, and it should be a straight line, let's say that this is a point in time. I do not have any leg that's in 0 at the same moment of time with another leg, okay? So here we have a green leg that's in 0, but I do not have any other leg of the circuit that is in 0 at the same time. So my motor is getting, or my whatever I'm using the power for, is getting power without that pulse of the modulation of going through 0. There are 3 reasons why three-phase power is superior to single-phase power. First, the horsepower rating of three-phase motors and the amperage rating of three-phase transformers are about 150% greater than single-phase transformers and motors of similar sizes. The power delivered by three-phase power supplies is more constant. While it also moves through 0 3 times every cycle, not all 3 legs move through 0 at one time, and that's what I was trying to show you. In a balanced three-phase system, conductors need only be about 75% the size of a conductor for a single-phase 2-wire system. In other words, I can use smaller wiring. Three-phase power is supplied mainly to larger commercial and manufacturing customers. Three-phase power requires a third line from the power company as well as three-phase breakers. So remember, a single-phase generator spins a magnet inside of a coil of wires. The magnet has a north and a south pole, which generates alternating current in the wires. So I'll show you an example of this on this slide. So this is generating a single-phase power. Okay, we have a coil of wire and a north and a south magnet. Generating three-phase power, there are 3 coil of wires set inside the generator, exactly 120 degrees apart from each other electrically. As the magnet moves through each of the 3 windings, the current produced is 120 degrees out of phase with the other 2 windings. So when we generate three-phase power, okay, we have 3 windings. One of these is going to be L1, one's going to be L2, one's going to be L3. They're exactly 120 degrees out of phase with each other. Now, this doesn't mean that they're separated mechanically. It means electrically they're 120 degrees out of phase. This out of 120 degree difference produces 3 sine waves that are exactly 120 degree out of phase with each other. And this is what is produced. So as we move forward in time, we do not have any two windings in 0 at the same time. So when we connect from L1 to L2, we always have, okay, a voltage differential between any 3 wires at any time. If you notice on the sine waves, there's no more than a single sine wave going through 0 at any one time. In a single phase system, this same effort can be produced by a capacitor on the start winding of a motor. Because again, capacitors block DC but pass AC current, but there is a delay. Okay, so what we're doing with a start winding when we have a capacitor on it is we are putting that winding out of phase with the run winding by the use of a capacitor. So single phase systems use a disconnect with 2 fuses. They disconnect line 1 and 2. 3-phase systems will use 3 fuses or disconnects. 3-phase disconnects will use L1, L2, and L3 as all 3 legs are required. So a residential or single-phase breaker panel has 2 hot legs coming in from the top. So again, we have 2 hot legs. Okay, I have L1 and I have L2. And I have a neutral bar. Okay, L1, L2. So each of our breakers connects to the other. Now, if we have a double pole breaker, it actually flops across both lines and it gives us L1 to L2. A 3-phase commercial panel has L1, L2, and L3 all running through the same panel. We also put a neutral down here at the bottom. It's important to know the phase of the system you're reaching into. As there's no neutral, all of the legs in a commercial breaker panel are live or hot. Now again, we do have a ground here at the bottom. We can talk more about this as we move forward, or we talked about it in the last video. We have a ground here. But you got to be very careful in a commercial panel. You do not touch this leg and come close to this leg. We can actually generate an arc that is extremely dangerous. Make sure you use your meter to verify the panel. HVAC technicians may not do any work inside a panel other than verifying voltage. Again, let me repeat that. HVAC technicians may not do any work inside a breaker panel other than verifying voltage. Your licenses do not allow you to do any work, and this is in almost any state in the country. You cannot do work inside a panel. Be careful. Okay, so at this point, we've talked a little bit about 3-phase motors. Okay, if you're at a classroom, this is a great time to ask any questions you have from your instructor. We're now going to move on to 3-phase motors. So 3-phase motors, with comparison to single-phase motors, are more rugged, more reliable, more dependable than single-phase motors. The most common type of 3-phase motor used in HVAC industry has a squirrel cage induction type. 3-phase motors are considerably stronger than the single-phase motor. 3-phase motors do not require any start components. You will not see a capacitor on a 3-phase motor. Now, that doesn't mean that if you're going into a 3-phase rooftop unit, you won't see a capacitor, because sometimes the condenser fans and the blower motor, the indoor blower motor, are not 3-phase. It might just be the compressors that are 3-phase. So just be aware of that. 3-phase motors are much more able to start a heavy load. 3-phase motors have a set of windings. All the windings have close to the same resistance. The windings are 120 degrees out of phase with the other windings. Remember, the rotor is the moving part of the motor and contains the magnet. The stator is the stationary part of the motor and contains the windings. There are 2 main winding configurations found on 3-phase motors. You have the delta winding and you have the starter Y windings. Both of these windings allow you to have high and low voltage hookups. So the star winding of a 3-phase motor, okay, which could also be a Y, okay, You could have a low voltage hookup where you use L1 goes to both T1 and T7, L2 to T3, 2 and T8, L3 to T3 and T9, and then you'll tie T4, 5, and 6 together. Okay, this will all be on the motor nameplate. Now, the same motor might allow you to use a higher voltage. You'll take L1 to T1, L2 to T3, L3 to T3, and then you'll tie T4 to T7, T5 to T8, and T6 to T9. And if you look at this closely and actually draw it out, you'll see, for example, if we do this for the high voltage, what are we doing? We're actually increasing the length of the windings. Okay? If we do this for the, let me see if I can, okay, if we do this, let's change pen color. I'll go to blue, and if I follow this direction, we're going to tie T4, T5, and T6 all together. Okay, so basically what I'm doing is I'm creating another central point, okay? And then I'll connect L1 to T1 and T7, okay? L2 to T3 and T9. So now here I'm putting some motors in, some windings in parallel with each other. So again, look at the labels, because this can be extremely important when you're hooking up and connecting motors. Now, there's a delta winding configuration as well. Again, we have a high voltage and a low voltage hookup. The high voltage, all we're doing again is extending these motor windings. Okay, the low voltage hookup, okay, we're creating two delta windings. And again, if I draw this out on the low voltage hookup, let's take a look at what we're doing here. Okay, I'm going to connect L1 to T1. Okay, then I'm going to connect T6 to T7. I'm going to connect L2 to T2. And I'm going to connect T4 and T8. And then I'm going to connect L3 to T3, and I'm going to connect T5 and T7. So basically what we're doing here is we're actually creating a parallel circuit. And again, it's very important to read the labels, because your motor windings are not the same in every manufacturer. So read the labels on the motor. It's important. Most, if not all, three-phase motors will come with directions on what windings or leads to tie together to give you the proper configuration for voltage. Make sure you carefully follow these directions, as three-phase motors are pretty unforgiving. The voltage levels and the amperages will melt those windings fast if you don't have them configured correctly. So all three-phase motors can first be checked by disconnecting from the circuit and reading the resistance of all the windings with an ohm meter. If the reading is 0, the motor is shorted. So if you go from L1 to L3 and get a reading of 0, the motor is shorted. If the reading is OL or infinite, the motor has an open winding. There's normally a 1 to 50 ohm resistance based on motor size. The smaller the motor, most often the higher resistance of the windings. The larger the motor, the lower the resistance of the windings. It's also very important with three-phase motors to check for proper rotation. The proper rotation of a three-phase motor must be confirmed anytime the equipment is started up or repaired. I actually went to a service call on a packaged rooftop air conditioning unit where the customer was complaining of no cooling. All the motors were running backwards because whoever started it up did not properly diagnose, did not check for correct rotation. When a three-phase motors are running in reverse, take and change any two of the lines. Okay, so if your motor's supposed to be running in a clockwise direction, and if it's running in a counterclockwise direction, swap L1 and L2. If that doesn't correct the rotation, swap L2 and L3. Three-phase motors can be made to run in reverse based on the phase of the power coming into them. Again, to put the rotation correctly, swap any two of the three-phase lines coming in. So that's a little bit about three-phase motors, and you'll understand them much better once you start working with them. But hopefully this gives you a background of the three-phase power supplies and the three-phase motors.